Alright, I wanted you guys to do a warm-up on area and perimeter in terms of x because this will be on your next exam. I'm going to throw it in there with the factoring test. So let's look at this first figure, the square. To find area of a square, it's side times side. Now our dimension, our side, is a binomial. The only way I can multiply 3x minus 4 times itself is to use that FOIL method. You really cannot do this in your head. So you've got to write out the two parentheses next to each other and then use the FOIL method. 3x times 3x is 9x squared. Then you're going to get a negative 12x, and then you get another negative 12x, and at the end, watch out for your signs here, you get a positive 16. So the area of this square, once you simplify it, is 9x squared minus 24x plus 16. That's the area. Perimeter isn't as complicated. All you got to do is add all four sides, and they're all exactly the same on a square. Or take one side and multiply it by 4. So the perimeter here would be 12x minus 16. So check your answers. All right, number 2, let's move on to the circle. Now, the area of a circle is very similar to area of a square. Instead of side times side, it's going to be radius times radius. Now, you have to make sure to put pi in there, and you also have to make sure that you know what dimension you're given. I gave you the diameter here. You need diameter for circumference. You need radius for area. So I would write down both of them and determine which it is you're trying to find. For radius, I'm going to take the diameter and divide it by 2. It's half of the diameter. So the radius here would be 2x plus 1. Now I'm ready to find my area. I'm going to do radius times pi. So I've got to do 2x plus 1 times 2x plus 1. And then don't forget, I'm going to wrap the whole thing in parentheses and put a pi on it. So I'm getting 4x squared plus 2x, another plus 2x, and then a plus 1 on the end. Simplify that, you get 4x squared plus 4x plus 1, and then wrap the whole thing in parentheses and stick a pi on it. That's the area. Circumference is much easier, especially since you already knew the diameter. Circumference is just diameter times pi. So since you know the diameter is 4x plus 2, I just need to stick a pi on it, but you got to be careful. You need to remember you got to put the whole thing in parentheses. So there's my area and circumference for the circle. All right, a triangle. The biggest thing that kids mess up on a triangle when you're finding area of a triangle is kids forget to divide by 2. So please don't forget that step. Area of a triangle is base times height divided by 2. So I've got to do 3x minus 2 times 4x minus 6, and at the end I'll divide all those coefficients by 2. I got to use FOIL again. 3x times 4x is 12x squared. 3x times negative 6 is negative 18x. Negative 2 times 4x is negative 8x. And again, watch your signs here. At the end I get a positive 12. Simplify this, you're going to get 12x squared minus, 26x plus 12. All of that has to get divided by 2. When I divide by 2, the only thing affected is the 12, the negative 26, and the 12 back here. So my final answer here for area then will be 6x squared minus 13x plus 6. That's the area of that triangle. Again, perimeter is usually simpler. Perimeter is just add up all of the sides. Please don't include the height in perimeter. Perimeter is always the distance outside a figure. So I need the base and then these two legs. So I'm just going to add it up from the picture. 3x plus 2 is 5x plus 2 more is 7x. And then I've got a negative 2 plus 1, which makes just 0. So the perimeter here is just 7x. And we did not use the height when we found perimeter. All right, and then the last one. Area of a rectangle is length times width. So we're going to do 3x plus 4 times 2x minus 3 using FOIL, of course. That's going to give you 6x squared minus 9x plus 8x, and then minus 12 at the end. That's 6x squared minus x minus 12. That's my area. Perimeter, add all the sides. Don't forget, you've got to double the length and double the width. You've got to include all four sides for perimeter. I usually write them in on the picture and I count them up from the picture. 3x and 3x is 6x, 7, 8, 9, 10x. Plus 4 and plus 4 is plus 8. Minus 3 and minus 3 is a minus 6. So my final constant total is a plus 2. 10x plus 2 was my perimeter. Alright, so be ready for your next major exam. You will have area and perimeter in terms of x. Everybody get out your homework. We are going to grade page 190, 10 to 24. Now I know you won't be able to ask questions because this is a recording. Just keep in mind which ones you had problems with. I'll pass it back to you next time I see you and we can go over questions when I get back. But do check your answer for right and wrong. I will give you partial credit. So if you get one answer correct and one answer wrong, you could just put 1x. If you don't miss anything, you don't put any x's. If you miss both of the questions, though, you got to put 2 x's there. So for example, on number 10, the roots were 1/2 and 5. And again, you could have written it several ways. You could have written x equals 1/2, x equals 5. You could have written them as points, 1/2, 0, and 5, 0. You could have written them in set notation. So if you didn't write it as a set, that's okay. But if you didn't get either one of these answers correct, then that's 2 x's for number 10. So I'm going to write my answers in set notation just because I think that's easier. Again, you could have written it any of the 3 ways we talked about yesterday. Alright, number 11. I'm seeing 1/3 as one of the roots and -5 as the other one. Again, if you got one right and one wrong, it's 1x. If you missed both of them, it's 2 x's. Hopefully you didn't miss any, so no x's. Number 12 is -3/2 and +5. Whoops. -3/2 could also be written as -1.5 or -1.5 if you like decimals. So if you didn't have it as -3/2, that's okay. You could also have -1.5 or -1.5. Alright, number 13. The 2 roots here were 10 and -10. Number 14. 0. Some kids forget to write down the root of 0, and -13 were the 2 roots. Number 15 also had an answer of 0 as one of the roots, and the other one was 7/3. Again, 7/3 could be 2 and 1/3. And if you just love decimals, you had to write it correctly. If you put 2.6 repeating, that's okay. But it's not 2.6, it's 2.6 repeating. I'm sorry, 2.3 repeating. Whoopsie. 2 and 1/3 would be 2.3 repeating. Alright, number 16. 16 was 3/2, which again could be 1.5 or 1.5. The other root was -8. 17. 5/3. The other one was -7. Again, 5/3 could be 1 2/3 or 1.6 repeating. Number 18 is 1/5 and -7 were my 2 roots. If you're just a decimal lover, 1/5 is 0.2. Number 19 was 7/2. The other root was -6. Other versions of 7/2 include 3.5 or 3.5. Number 20 was 7/5 and +3 were the 2 roots. 7/5 and +3. 7/5 could also be 1 2/5 or 1.4. And then +3. I'm running out of space here. 21 is -7/2, which is the same thing as -3.5 or -3.5. The other root was -8. 22 had 3 answers, so every answer is a check or an X here. If you miss all 3 of them, you got to put 3 little X's. It was 0, 6, and -6, and it could be in any order if you did it in set notation. Or 3 points, 0, 0, 6, 0, -6, 0. Same thing for 23. -2, 0, and 2 were the 3 roots. And 24 was -7, 0, and 7. So take a minute to count up every single x. I know there's a possibility for lots of x's. That means each question won't be worth as many because there's so many possible x's. So count them all up very carefully. Now that's 33 total answers here, so they're only 3 points each. So every little x is 3 points apiece. 3 points apiece. So please figure out your grade. Multiply how many you missed by 3, subtract that from 100. Make sure your name, number, and now your score are on your paper and pass them up for the substitute to collect. All right, our lesson today is kind of an extension of yesterday with one extra little step. Today's notes are called standard form of a quadratic equation. Standard form of a quadratic equation. All right, as an equation, or quadratic equation, is considered to be in standard form if these three things happen. The coefficient of x squared, in other words, the value of a is what goes in front of x squared, has to be positive. Number 2, the polynomial, the equation, has to be equal to 0. And then the last thing is the terms are in descending order of exponents. The terms are in descending order of exponents, which is what all of our problems have looked like. They've all been rigged for us to start with the x squared term, and then the x term is in the middle, and then the constant is at the end. They're in this form: ax squared plus bx plus c equals 0. This is what it means to be in order. You've got your x squared first, then your plain old x, and then your constant at the end. We want to set it equal to 0, and you want to make sure you make a positive, because we're going to have some choices when we do this. We can move the terms around. We are going to force the a to become positive because we're going to have to factor this, and it's much easier to factor if your a term is positive. Now, all the ones you did last night were rigged. They were already in standard form. They were already in order. A was always positive. It already equaled 0. The ones you're about to see are not going to be in order. You're going to have to do some rearranging first. And that's the only extra step. Once you get them rearranged, you solve it just like normal. Okay, here's our first example. Number 1, n squared minus 12 equals 4n. Okay, first of all, a couple of things that clue me into this is not just a regular factoring problem. It's got an equal sign. That means this is an equation that we need to actually solve. Now, it's not a normal equation. How do I know it's not a normal equation? It's got an exponent of 2. It's a quadratic equation. The way we solve quadratic equations is not the same as how we solve normal equations. Quadratic equations, you want to get everything on one side, and you want the other side to equal 0. So if we look at this problem, all of our terms are not all on one side. We have a 4n over here on the right. You have two choices. You could choose to move both of these guys to the right. To get rid of an n squared, for example, you would subtract n squared. To get rid of a minus 12, you would add 12. So we could do that. However, to be in standard form, you want your x squared, or in this case your n squared term, you want it to have a positive number. So you always want to locate your x squared or your n squared. If it's positive, you don't want to move that part. So I don't want to move n squared. And minus 12 is already on the same side with n squared. So the only thing that I really want to move then is this guy, the 4n. That 4n has got to move to the other side of the equation. And you got to know where to put it. I need to insert it in the middle here because I want to go in order of x squared, then x, and then the constant at the end. So we're just going to rearrange this a little bit. To make the 4n move to the other side, what we're really doing is we're subtracting 4n's, and I'm just going to insert it in between these two terms. So now I'm going to have n squared minus 4n minus 12 equals, now what happens over here? I had 4n, but I took them away, so now I've got a 0 over here. So now in just one easy step, I have put this into standard form. Now I'm ready to solve it. This is a quadratic function. We're finding the zeros. I know that because it's set equal to 0 now. And the way we do that is by factoring. Okay, and I'm going to go kind of quick with the factoring. Because you should already know how to do the factoring part. We're just going to focus on how to rearrange it. And then you should factor it. You should be hopefully good at that by now. The factors of 12, or I'm sorry, negative 12, that would add up to negative 4. I think it's going to be a 6 and a 2. And that would have to be a negative 6 and a positive 2. If you multiplied this back, you'd get exactly what you have up here. Now remember, these are factors. We want solutions. So we have to keep going. I know I need solutions because I had an equal sign when I started this problem. So that means n plus 6 could equal 0, or n plus 2 could equal 0. Here you would get negative 6. When you subtract 6 from both sides, here you would get negative 2. So this equation has two different solutions. Now I'm not going to make you do this, but you could check them. I could go back all the way to my original problem. Negative 6 should work in place of n. So let's just try this. What's negative 6 squared? Negative 6 times itself would be positive 36 minus 12 should equal 4 times negative 6. So I put a negative 6 in everywhere I saw an n. Well, 36 minus 12 is 24. Oh, I'm sorry. I'm glad I checked it. Look what I caught a mistake. Alright, great, and I cannot start over. Alright, the factors were n minus 6 and n plus 2, but for some reason when I wrote it down to solve it, I didn't write it right. If n minus 6 equals 0, then n would be positive 6. If n plus 2 equals 0, then n would equal negative 2. So I had one of them right, one of them wrong. So don't do, I was just showing you what I didn't want you to do. Alright, let's check it. 6 squared. 6 squared is 36. 36 minus 12 is 24. And if I put a 6 over here, I'm also going to get 24. I can also try negative 2. Negative 2 should work as well. Negative 2 squared is 4. Positive 4. Negative 2 squared is positive 4. 4 minus 12 is negative 8. Put a negative 2 over here. 4 times negative 2 is also negative 8. Both of those do work. Alright, number 2. Negative x squared minus 15 equals 8x. Alright, now look carefully at this one. Sometimes kids tell me they want to move the 8x because that would only require one thing to be moved. And that's true. However, you need to always look at your x squared term. You want it to have a positive number in front of it. And right now, x squared does not have a positive number in front of it. It has a negative number. So that means I want the negative x squared to go to this side, which means the negative 15 is also going to have to go to this side, and then I'm going to have a 0 over here. Basically, when you move something across an equal sign, all that happens is it changes signs. Like to make a negative x squared go away, you're going to add an x squared to both sides. To make a negative 15 go away, you're going to add a 15 to both sides. And again, we want to also put it in order. So you can almost kind of do this step in your head. I usually don't write down the plus x squared and the plus 15. I just know that these two things have to move. And when I move them over here, they're going to change signs. The 8x is not going to change at all. It's not moving. It's staying put. And again, you want them in order. So I'm going to move the negative x squared to the other side. It's going to become positive x squared. I want to leave that plus 8x, that's a positive 8x, I want to leave it in the middle. And the minus 15, when I move it over, is going to become a plus 15. So these two things had to change. They had to go over there and join the 8x that was on the right. Now it's in standard form. It's set equal to 0. It's in order of descending exponents, and the x squared term is positive. I'm ready to start factoring and solving this thing. And the factors of 15 that can add up to 8 are 3 and 5, and they would both have to be positive. So once you get everything moved around, it's just like last night's homework. If x plus 3 equals 0 and x plus 5 equals 0, to solve these little baby equations, I'm getting a negative 3 for this one and a negative 5 for this one. All right, number 3. Negative x squared equals 5x. Okay, we want our x squared to be positive. Right now it's negative, so I always look for my x squared first. If it's positive, I leave it where it is and everything else comes to its side. If it's negative, then I know it's got to move and everything with it has got to move and the other side stays the same. Well, this one happens to be negative, so it's going to move to the other side. So I'm going to add an x squared to both sides. That's what's happening here. I'm adding an x squared to both sides. So I'm going to end up with 0 over here and positive x squared plus 5x over here. And some kids don't like it when it's written like that. They want the 0 on the right. That's fine too. You can then rewrite it to have the 0 on the right. But you definitely need the 5x to stay positive, and the negative x squared comes over there to join it, and it becomes positive, and then set it equal to 0. Okay, this is one of those binomials. The only thing you can do with a binomial is either GCF or difference of two squares, and this is obviously not the difference of two squares. This is a GCF problem. Always look for a GCF first anyway, and the GCF here is x. Factor an x out, you'd be left with x plus 5. Here are my two factors. Remember, you set each little factor equal to 0, and you keep on solving. This one's already solved. Sometimes actually one of your solutions is the number 0. We're almost done with this one. Move the 5 over, and you get negative 5. So 0 would work in this problem, so would negative 5. Let's check it real quick. All right, if I square 0, I'm going to get 0. The opposite of 0 is still 0. If I put a 0 in on this side, 5 times 0 is also 0. Absolutely, the 0 works. It's a little trickier to check negative 5. So remember what's happening here. You're doing the opposite of negative 5 squared. Well, negative 5 squared is 25. The opposite of that is negative 25. Put a negative 5 in for this side. 5 times negative 5 is also negative 25. So I checked my work real quick, and they both do work. All right, number 4. 4 minus 7x equals 2x squared. All right, I always look for my x squared. If it's positive, I don't want to move it. I want everything else to move. 2x squared is positive. That means I want both of these guys to move over there to be with the 2x squared. So that's going to be 2x squared plus 7x. Because when I move this negative 7x to the other side, I do that by adding a 7x to both sides. And this positive 4 becomes a minus 4. Because to get rid of a positive 4, I subtract 4 from both sides, so that these cancel out and I'm left with 0. And on the other side, I would have 2x squared plus 7x minus 4 equals 0. There is no GCF. I start factoring, guessing and checking. This could either be 4 and 1 or 2 and 2. I think 4 and 1 is going to be the winner. This would give me 8x. This would give me 1x. I need a positive 8 and a negative 1. So here are my two factors. Remember, you keep on going because it's an equation. You want solutions. This would be 2x equals positive 1. Divide by 2, and x equals 1/2. Over here, move the 4 over, you get x equals -4. So again, one extra step. Real quick, one word problem. The square of a number is 6 less than 5 times the number. And your directions are to find the number. The square of a number is 6 less than 5 times the number. Alright, well, a number is where we would put our x. So what's the square of x going to look like? That would be x squared. That's where our equal sign would go. Be careful with this phrase here. How would I write 6 less than 5 times x? 6 less than 5 times x would be 5x minus 6. So I translated the words directly into an equation. Now I got to rearrange it until it's in standard form. That would be x squared minus 5x plus 6 equals 0. And then I'm going to factor it and solve it. You will have a couple here, and I don't think it's any big deal. I think you can take these words and make it into an equation. Then put it in standard form. Decide what's got to move, and it's going to change signs when you move it. And then it turns into just like last night. Now you got to be careful here, because look at 6. 1 times 6 could make a -5, but so could 3 and 2. So you got to think about your signs here. If the last term is negative but the middle is positive, positive but the middle is negative, that means both of your signs have to be negative. And if both of these were negative, it's not going to make a -5. So it's got to be the 3-2 combo. Alright, so there's my factors. Keep on solving it. If x minus 3 equals 0, then x would be positive 3. If x minus 2 equals 0, then x would have to be positive 2. So here are my two solutions to that word problem. Alright, your homework is homework that you're going to start in class right now, page 194. I'm going to give you several different sections. There's one section where it's got some whole number answers, one section where it's got some fraction answers, and one section where it's word problems. So on page 194, I want you to do 1 through 6. (19 through 23), and then 25 through 28. 1 through 6, those should be whole number answers, and there should be 2 answers apiece for all of those. 19 to 23, most of those, not all of them, but most of those are going to give you fraction answers, at least on one of the factors, if not both. So expect fractions on those problems. And then 25 through 28, those are the word problems, and I want you to get some practice setting up and solving them. Those should be whole number answers. Alright, so that is your homework, but you need to start it right now in class. If you have any questions, I will have tutoring Thursday morning.